Yeah, thank you. My name is Swarnim Soni, and I'll be taking today's live session. I'm a member of the instructors team. So let's wait for a couple more minutes so that more people can join, and we'll start. Okay, I think we can begin now. Welcome to the Machine Learning Techniques course. I hope that you have watched all the videos and gone through the practice material. Let me share my screen. All right. Since this is the first session, I'll just go over a few things that might, help you better understand and prepare for this course. These are the books that you can refer to better understand. Some textbooks for more reading on the topics being covered in this course. I'll just tell you one thing before we proceed. So this course is a bit different from any other machine learning course. In this course, you will not just implement any machine learning method with the help of machine learning libraries. On the opposite, you will be implementing the machine learning algorithms and their functions with the help of from scratch using Numpy library. Numpy library is vectorized implementation of matrices, and it actually makes the execution much quicker, and it'll help you to write mathematical notations, vectorized mathematical notations very quickly. So that's what we are going to use. Okay. Okay. So first week is mainly introduction about the machine learning as a general topic. And there's a week 0 also, which helps you prepare, for how to use Numpy. Okay, so let me go through week 1 content before I go to Numpy content. Okay, okay. So should we begin looking at the questions? Does anyone have any questions?
I want to know that role of in modern detection.
Sorry, I'm not able to hear you clearly. Can you write your question in the chat box? Yes, Indanil, tell me.
Sir, I have a doubt in week 0 actually in practice assignment, week 0
Okay.
practice assignment.
Okay.
So, in the question number 3, we have this dot product of 2 vectors, but the correct option also has this option 1, x at the rate y. So how is this possible?
Okay, okay. So, can I request you to hold on for a few some time so that we
Yeah, yeah,
finish
sure.
the week one content before we go to
Yeah,
week
yeah, sure.
zero?
Okay, sir.
Okay. Yeah.
Yeah.
All right. So, the first activity question is machine learning is subdomain of artificial intelligence. Is it true or false? So, what do you think?
True, true.
True. That is true. Yes. Artificial intelligence is about recreating human intelligence or human intelligence like mechanisms with the help of machine. And machine learning definitely falls under it. Which of the
So
following?
somewhere I had read that even artificial intelligence comes under data science. So is that hierarchy correct?
Sorry, I'm not able to hear you clearly.
So somewhere I have read that artificial intelligence itself comes under the data science. Like the, is that
Okay.
correct?
Artificial intelligence comes under data science. That's a big statement. I have to look into this. Okay. So please create a discourse post. I'll definitely try to answer there. Okay,
Sure, we'll find that article.
sure. Uh, Moving on to question number two. Which of the following is are true about machine learning? First option, machine learning helps in learning parameters of model. What do you think of this?
So true.
That is true. Okay. What is this? What do you think of the second option? Machine learning helps in mapping input to the output. Assuming that we have such input-output pair,
True.
that is also true. Yes. Machine learning helps in detecting patterns automatically.
True. True.
Yes, that's also true. Machine learning helps in making predictions by using historical data.
True.
True.
That's also true. Yes. So for question number two, all the options are correct. Moving on to question number three. Consider the following statements. Output labels are present in the training set in the case of supervised learning. Output labels are present in the training set in the case of unsupervised learning. Which of the above statements are true?
Option A. Only.
Right, right.
Option A is correct. Yeah.
That is true. So labels are characteristic property of supervised learning. In a data set, if the labels are accompanied by the sample inputs or the data inputs, then it falls under the supervised learning problem. Yes, so only statement one is correct. Unsupervised learning is specifically defines the problem where the labels are not there. Okay, moving on to question number four. Which of the following is are true about training data? It is used to train machine learning model. What do you think of this?
True.
True.
True. It describes input-output pairs.
True.
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 Some,
Assuming that there are input-output pairs. Yes.
sir, for unsupervised learning, is it possible to have output also in training data?
No. So unsupervised learning, by definition, it doesn't have labels associated with samples.
So option two is kind of ambiguous, right?
Well, it assumes that the input-output is pair is available. Otherwise, you wouldn't. How would you describe it?
Okay.
Input with nothing else, right?
Okay.
So
Okay.
yeah. So option number two assumes that there is an input-output pair. Okay. Option number three, it describes the nature of data.
True.
True.
True. Right. Okay. Going over to question number five. What does a machine learning model represent? It represents a mathematical description of input data. That is option number one. Option number two is mathematical description of output data. Third option is mathematical relationship between input and output. And fourth is all of the above.
Option C.
Option C. That is true. So in machine learning, we have data, we have input data, we have output data, but we don't have a mathematical relationship between those two, and that's what we want to, properly figure out with the help of machine learning. True. So let's check answers. Okay, we got all of them right. Okay, so there are some questions in the chat box. Let me go through them. Give me 1 minute and I'll go to next set of activity questions. Okay, so Anushka has a question and she has received some answers from fellow learners also. So the question is about learning rate. Okay, so what is the ideal? What is an ideal learning rate? So okay, Anushka. So we'll definitely study about this one in week 2. So the answers that you received are actually quite on target. So I'll briefly tell you what learning rate helps you do. Learning rate helps you converge your model to the ideal one that you want to converge, which minimizes the error. And learning rate decides how quick or how slow you achieve this. And sometimes too small and too large can, instead of making your learning process better, they can create trouble and create problems, and it might be possible that your learning doesn't happen. So or you end up expanding too much computation power. So we'll look into the details of learning rate in week 2. Okay, let's go to next set of questions. Okay, which of the following is more suited to traditional programming approach? Pattern recognition, speech recognition, weather prediction, or array sorting?
Both options.
Array
Option
sorting.
number 4. Yes, array sorting. Just for a minute, let's dive a bit deeper into this question. Why do you think that array sorting is suited for traditional programming approach?
Because for that, we already have a mathematical model which we can use.
You're absolutely right. Yes, that's the reason array sorting is traditional programming. Okay, going over to question number 2. In machine learning, loss function, what does loss function do? It captures the time and energy lost during implementation of machine learning model. Option number 2 captures the money spent in building a machine learning model. Option number 3, it captures the difference between actual output and the output predicted from machine learning model.
Option
Which one?
Option C.
Option C. Okay. Going to the next question. Optimization is to find parameters of the model such that loss is minimized, to find the minimum value of input features, to find the maximum value of output, to find the maximum value of parameter in the model.
Option A.
Option A. That is right. We want to minimize the loss, and that's what is done by optimization procedure. Question number 4. By evaluation of a machine learning model, we mean finding performance of a model on training data, finding performance of model on test data based on some pre-decided metric, fitting the model to the input data, finding the mathematical relationship between input and output.
B.
Option B.
That is right. Okay. Going over to question number 5. A machine learning model will work well if training and testing data are from different distributions. Is it true or false?
False.
That is absolutely, that's true. The correct option is false. In machine learning, we assume that the testing and training data are coming from the same distribution. Otherwise, if they belong to different distributions, then your model's performance on test data will be very poor.
But so like when do we test with different distributions? Because we want the model to work for every distribution, right? In future. So
We cannot train a machine learning model that can work with all distributions if all those distributions are also not part of training data.
so it's only working for one type of distribution then.
Right. So whenever we have data set, so we assume that it has been generated by some underlying statistical process, and so by using the same process that data set has been generated. When we create training and test data, we split the data generated from assumed same process. So when we do this random splitting of training and test data, so more or less, if the data is sufficiently large in number, then more or less the distribution of training and test data is same. So we don't worry about whether our model will perform poorly because test data belongs to different distribution.
So test data will have different distributions, which has one distribution in common with the training data.
Sorry, I'm not able to hear you clearly.
Can you read? So I'm saying that testing data will have different distributions, but one of the distributions will match with the distribution of the training data, right?
No, test data and training data, both of them should have the same or similar distribution. Yes.
Okay.
Right. Okay. So let's check our answers. Okay. All our answers are correct. Let's go to next set of activity questions. Question number 1. No data, no ML implies what? Data is an absolute necessity to build machine learning models. Machine learning models can be built without available data. There is no feed of data for ML. More the available data, better is the chance of implementing an ML model. Which one of these do you think is true?
A and B.
A and D.
Okay, let's go ahead with that. By the way, fourth, it's true, but let's see if it implies this. Okay, question number 2. Input data in any form can be fed for training an ML model. Is it true or false?
False.
That is true. Yes, we cannot use just any raw data to train a machine learning model. We have to possibly, in most of the cases, we have to pre-process it before we train a machine learning model with it. Question number 3.
What kind of data is required for input data?
Can you please repeat?
What kind of input data is actually required?
Right. So see, machine learning models, they only understand numbers. Okay. So let's say in your input data, there is a column called city or gender. Then those things are not readily understood by machines. So what you have to do is you have to convert those to numbers. Right. So this is one form of pre-processing that you will definitely learn in machine learning practices. But this is just to give you an example. Other kind of pre-processing is scaling your even the input is in the form of numbers. Sometimes, not sometimes actually, most of the times you want to scale that numerical feature to a different range so that your machine learning model performs or trains faster. Okay, so input data in any form cannot be fed to training and machine learning model. Question number 3. Okay, so before moving on, do I make sense?
Yes, sir.
Moving on to the next question. Output labels can be continuous, discrete, real, and imaginary.
Option
Which
B.
one? Pardon me? B.
Option B.
Right. So by B, you are saying that 1, 2, and 3 are acceptable.
Yeah.
Continuous, discrete, and real. Right. And imaginary is not an option for machine learning label. True.
Yeah.
Question number 4. The nature of training data helps in selection of output labels, loss function, machine learning model, optimization technique.
Loss function, ML model, and optimization technique.
Loss function. Okay, so let's go one by one. The nature of training data helps in selection of output label. No, they are supposed to be independent. I mean, independently. So, I mean, there's no dependence of output label on training data. Loss function. The nature of training data helps in selection of loss function. The nature of training data. Can you give an example?
So if we have continuous data, some like regression, then we use MSC or squared sum error. Then in that case, we are assuming that that function is the correct loss function.
That's true. That's true. Machine learning model.
Excuse me, sir. Sir,
Yes.
but MSC, those are not loss functions, right? Those are the measuring parameters or kind of means how well our model is performing.
Right, right. So see, mean squared error. They can be both. They can
Yeah,
be
for a
evaluation metric as well as
linear thing I
loss
can.
function. Yes,
Hmm.
they can be both.
But in generalized case, we can't say that.
Well, since they are used as both types of functions, loss function as well as evaluation metric, then it is fine. We can use it.
Okay.
The machine learning model. True. Optimization technique. Well, it depends. It doesn't depend upon the training data. Optimization technique depends upon loss function. What do you think?
I'm not sure about it. Optimization technique.
Okay, so okay, just to jump in a few weeks topics. For example, let's say you are working with gradient descent, which is an optimization technique, right?
Yes.
Does it work with all loss functions?
No, it has to be a convex function.
Yes.
That's true.
Uh,
True. True. So your loss optimization technique is dependent upon a loss function. Not all loss functions can be optimized with gradient descent. Okay, let's see what has been configured as the answers of this question. Okay, so maybe it is indirect. So loss function is, if it is decided by the help of training data, then optimization technique is decided based on loss function. Okay, let's see what's the correct answer for this. Evaluation metric used for ML models is always the same, irrespective of the context of the problem. What do you think of this?
False.
Yes, for different type of machine learning problems, we use different evaluation metric. For classification, we use something else. For regression, we use something else.
So could you elaborate on why the output can't be complex?
Why?
The output can't be complex.
Output cannot be complex. Can you give me a real world example where you want to predict real as well as imaginary component of anything?
I'm not sure of that, but I don't see a reason on why it can't be.
See, so there is something else a bit parallel to that problem. So let's say you have historical data of weather, the humidity, temperature, wind speed, direction, and so on and so forth, right? And what you want to do is you want to predict the temperature. What will be the temperature or average temperature, or yeah, uh, for any day after 1 week. So let's say you want to predict the temperature of the day 1 week in future. Okay. Which do you think this is an acceptable machine learning problem?
Yeah.
Okay. Now imagine not only you want to predict the temperature, you want to predict the humidity also, right? Okay.
Yeah.
So now you don't want to just predict one quantity, you want to predict two quantities. Okay.
Yeah.
So that is still an acceptable machine learning problem. It's a multi-output machine learning problem. So the first one, just predicting the temperature, you want to predict only one quantity. If you want to predict two quantities, temperature as well as humidity, then it becomes a multi-output regression problem. So by imaginary component is it will be definitely independent of real component, right? Real and imaginary part of complex numbers are independent of each other, right?
Yeah.
Right. So if you want to predict two things, you can definitely do that. But we don't call it imaginary. It's a real quantity. It's not a virtual component. Okay, and that's why fourth option is not suitable.
Okay. So in like real world data, we don't really encounter problems which involve us predicting something like which involves imaginary numbers in some way.
Yes, yes, it doesn't. It doesn't at all.
But it isn't a hard and fast rule that machine learning problems can't output imaginary uh,
See,
numbers.
imaginary is a way of looking at some of the mathematical problems analytically. We don't encounter any data sets where we want to predict imaginary numbers.
Okay.
So, Kumar, you had your hand raised.
Yes, sir. Just I want to know more little just you told that one thing that if I want to with the temperature, I also want humidity. So it is the multi-way of output. So can you explain little more?
Kumar, sorry, I did not. I lost you in between. Can you please post your question in the chat?
Okay, just you told that one thing. Can you hear me, sir?
Yes, yes, I can hear now.
Yeah. You told that there will with temperature we can also know the humidity. So what
Right.
is the multi output from the machine learning? Can you explain more? Because I was thinking to get the temperature, I have a temperature data in the back. To get the humidity, I have another humidity. So I can do individually. How it is the multi output? So that's I
Right,
want.
right. So, if you want to look at you want to decide whether the problem is single label or multi-label, you will have to uh, look at the cardinality of the output for a single training data. Okay, so I'm not going to the details of features. You can assume they could be anything, even more things that you want to imagine. If you want to figure out if it is single label or multi-label, you have to look at the cardinality of the output label only. Okay, so features don't matter for that. Now, if I want to calculate only one thing for every sample, or predict one thing for every sample, which is temperature, then it's a single label uh, prediction problem. However, if I want for every sample, I want to not just look into the temperature, but also humidity or any other quantity. Okay, so two quantities or more. If I want to predict for every sample, then it's a multi-label prediction problem.
So in the feeding, the training time, I have to give the all multi-level also the same way.
Absolutely right. Yes. If you want
Okay.
your model to make predictions, multiple predictions on the same data, then you have to train it in exactly same manner. That it is in the training process also it is looking at, or it is feeding upon multiple labels for every data, a single data sample.
Okay, so at the end we can think like that. It is the one by one output only, but on the actual everything is doing in the one mathematical calculation. That's only. Otherwise, it is the one by one, because for the every training data we have a suppose four humidity, temperature, the wind flow, and
Mhm.
the real feeling of the temperature. Also, sometimes weather gives that.
Mhm.
The suppose the four type of thing is there, and I'm feeding that four type of data for the every training data. So
Okay.
at the actually it is look that four output is there, but at the end it is one by one, isn't it? With only one mathematical calculation. Otherwise we can do four different training data, we can make separately with the one level also, we can do same thing, no?
That is absolutely right. Yes. So what you are discussing is now how would I, now you have this multi-label data, how are you going to create your model? Are you going to create single model for all the output labels, or you want to create one model for each of the output labels, right?
Correct. There's a two
Correct.
possibility I was want to know.
Yes, yes. Right. So yeah, you can go ahead with both of those, but uh, it depends upon the problem, which one works better.
Okay, so there is a no change in the mathematical way. The both result, both way, at the end prediction will come the same. Only in the first way, the our calculation or mathematical process will be easy, because all the four level I'm doing in the single calculation. That's only.
Right, right. So, okay, to answer that question, you will have to understand the transform feature transformation, which will come in week 3.
Okay.
Okay. So, yes, if you use exactly same transformations and everything else for even if you use the model for predicting multiple values, or different models for each of the output labels, if the transformations are exactly same, yes, this it could be that you will get the same answers. But if you have different transformations when you are training one model for each of the output label, then no, the outputs will be definitely, the predictions will be definitely different.
Okay, I got that. Thank you, sir.
Okay. Okay, so one of them we got it wrong. Loss function ML. Okay, so this is okay. Output label is not decided by nature of training data.
So, but how can optimization technique be decided on based on training data?
So it is based on loss. So looking at the training data, we can see if it is what kind of loss function we'll be using. And looking at loss function, we choose the optimization technique.
So we are looking
So
at loss
indirectly,
function.
it is deciding optimization technique. Okay, does it make sense?
Yeah.
Okay. All right. Let's go to next set of activity questions. Okay, so this is from uh,
Hello.
TensorFlow.
Hello.
Yes.
So don't we use the validation dataset to decide which optimization function to use?
Sorry, I didn't get you. Can you please repeat?
So don't we use the validation dataset to decide which optimization function to use?
Okay, there is some, sorry, there is some disturbance. Can you please write your question in the chat box?
Sure.
Okay, yeah, so Shreyash, your question is, don't we use validation data set to decide on optimization function? So by the way, validation set and training set, they will have exactly same nature, right? If okay, so the number of features, the types of features, both of them will be exactly same. So that is fine. So validation set or training set, you can use for this question interchangeably. And yeah, so training set and validation set, since both of them will have exactly same nature. So yes, you can say that training set can be used for deciding optimization function. Okay, Shresh. So basically, there's no for this question, there's no difference between validation and validation set and training set. Both of them can be used to decide the optimization function. By the way, since we will be using training set only for actually conducting optimization, so yeah, writing training set in this question is a better phrase rather than validation set. Okay, let's move on to the next question, which is on TensorFlow Playground. All right, so this is based on the TensorFlow Playground. I hope that you have gone through the website and played with it, made some experiments, and see how the training goes on. So question number 1 is, in TensorFlow Playground is described in the lecture, the orange points represent positive or negative. Which class do they represent? Anybody?
Negative class, second one.
That's true. They represent negative class. In the TensorFlow, yes.
Question: what does positive class and negative class mean?
Positive class and negative class mean okay. So basically, what you have is a data set in which the label has only two values. So we are calling them positive and negative. They could be anything else also, cats and dogs, cancer, non-cancerous, and things like that. Animal or plant. So basically, we have two classes in the data set. One we are the one we are interested in, we can call it positive, and the one we are not interested in, we can call it negative. Okay, does it make sense? Okay. Okay, going to question number 2. In the TensorFlow Playground described in the lecture, the blue points represent, I think that's a trivial one. Question number 3, a decision boundary used to separate the positive class from the negative class. That is true or false?
True.
It is true. Yes. So decision boundary is this in this diagram. The bright white line, which has slope of -1 approximately, I'm guessing. So anything above it is positive, anything below is negative, and this is the line which is used to make that decision.
But like, how does it separate a line? Like, separates it.
How does a
low numbers have positive or something? I don't know. Like how a line is like separating two things.
okay? So assume this is a 2D plane, right? There is x-axis, there is y-axis. Okay, and you have a equation of a line. This one, y is equal to -x. This, I'm guessing, assuming that it is very similar to y is equal to -x. I don't know the exact slope and intercept, but for the sake of this discussion, let's assume this is y is equal to -x. Okay,
Yes.
or y plus x is equal to 0. All right.
Yes, sir.
Now, all the points which fall below this line, if you feed in the values of their x and y coordinates, they will definitely be less than 0. And for all the points which are above the blue points, if you feed the coordinates of those into that line, you will get a value greater than 0. So by the help of that, we can actually make predictions whether it is a positive class or a negative class.
Can the decision boundary be a quadratic function, or does it need to be a linear function?
Very good question. Yes, it can be quadratic, it can be cubic, it can be something else also. All right. And I think in week 4, 5, and 6, we will be discovering, we'll learning about classification, and there you will see the decision functions or decision boundaries don't have to be just linear. They can be quadratic, cubic, or anything you want to experiment with it. Any kind of function you want to impose as decision boundary, you can do that and see how your model performs.
But like sometimes the blue points are in the orange like points, like they're mixed, so we cannot
True.
separate them. Like, so what
Yes.
happens in those cases?
Yes, in those cases, so for example, this decision boundary has 100% accuracy. Like it predicts all the blue points and the orange points correctly. But as you said, that sometimes the distinction cannot be made that easily. Some blue points actually fall into the orange territory, and some orange points fall into the blue territory. And in that case, we have some error, misclassification error, and our accuracy of the model will not be 100. We still want to optimize it. Still, we want our model to predict most of the labels correctly. But yes, in those situations, we possibly have some classification error. Okay. Question number 4. In the TensorFlow playground described in the video, the classification algorithm used this: logistic regression, linear regression, naive Bayes, or semi-naive Bayes?
Logistic regression.
That's the right one. Question number 5. In the TensorFlow playground described in the video, the loss function used is maximum likelihood, log likelihood, binary cross entropy, or mean squared error?
C, I think option C.
Yes, it's binary cross entropy. Question number 6. In case any one of you is confused, please go through that TensorFlow playground one more time, play with it, and try to observe the answers to these questions. Question number 6. In the TensorFlow playground described in the video, the optimization procedure used is gradient descent. Okay, gradient ascent, batch gradient descent, and batch gradient ascent.
Batch gradient
descent.
Okay, so this gradient ascent, batch gradient ascent and gradient ascent, both of these are not any kind of algorithms. Only gradient descent and batch gradient descents are. In the TensorFlow playground,
What is the difference between gradient descent and batch gradient descent?
good question. So the difference between these two is how many samples do you process before you change weights of your model? That decides whether it's a gradient descent or batch gradient descent. And there's one more variation, which is called stochastic gradient descent. So in gradient descent, if you go through your entire training set before modifying the weights of your model, even once, that is called gradient descent. In batch gradient descent, but sometimes, gradient descent takes a lot of time if you have huge number of samples. What you would want to do is, you want to take small chunks of your training data and make changes to your model parameters more frequently. In that case, what you do is you use some batches of your training data, and then for each batch you apply gradient descent, and that's why it is called batch gradient descent. Does it make sense? So there will be more information on variations of gradient descent in week 2. This will come. We'll definitely study gradient descent, batch gradient descent, and stochastic gradient descent in more detail. Okay, question number 7. In the TensorFlow playground described in the video, the activation function used is ReLU, sigmoid, 10H, or linear.
Sigmoid.
Okay. Question number 8. If the learning rate is too small, then number of epochs required to train machine learning model increases. The number of epochs required to train machine learning model decreases. Number of epochs required to train machine learning model remains the same. It may increase or decrease. Which one is the right answer?
Option A.
Option A, definitely true, because the number of epochs, if you keep the learning rate too small, the learning rate decides how quickly we converge to our ideal model, or I should say the optimized model. And if you keep it too small, we are going to take more number of steps.
So in the last 4 questions, like I know like we have used this function and this loss function and all, but I don't know why we have used these type of functions only. Why not others? Do we need to know the reason in this week, or do we need to memorize name?
Sorry, there was some disturbance. Can you please repeat that?
Yes, sir. In the last 4 questions, like I know that we have used this type of loss function and everything, but why have we used only these functions for this algorithm? Like I don't know the reason for that. So do we need to know the reason in this week, or like?
No, no, no. You are not supposed to understand it perfectly in this week because we have not introduced the classification problem. So TensorFlow Playground, the image that you saw, this blue and orange one, it works with binary classification only, and that's why you saw some binary cross entropy as loss function and so on. And so it is fine if you do not understand a few things about this. You will definitely understand them in more depth when week 4 comes in. Okay, and in this question number 8, this you can experiment with in TensorFlow Playground. However, you will definitely have more understanding of this in week 2. Why is this happening? What happens if it is too small, or what happens if it is too large? This will be covered in great detail in week 2.
Okay, sir.
Okay, let's check our answers. Okay, all of them are right. Let's move on. Okay, question number 5. Sorry, not activity question 1.5. Which of the following is our type of machine learning? Supervised learning, semi-supervised learning, unsupervised learning, or reinforcement learning?
A, C, and D.
A, C, and D. Why not semi-supervised?
Same. I don't think it's a type of machine learning actually.
Okay, I think it should be. Okay, let's see our answers. For now, let's keep it unchecked.
Yeah, sure.
Question number 2. Clustering is a type of supervised and unsupervised regression or classification. Which type of problem that is?
Unsupervised.
Unsupervised, absolutely. Because clustering, if anybody is not aware of this, clustering is finding out groups in a data set, unlabeled data set. So we don't have a label associated with samples. Question number 3. Which of the following are supervised learning techniques? Regression, rule learning, classification, clustering.
Regression and classification.
True. Regression classification. Supervised learning is marked by the fact that for every data sample, we have a label associated with it. It could be continuous in case of regression. It could be discrete in case of classification, but we definitely have a label. In rule learning, we don't have that. In clustering, we definitely don't have that. So yes, A and C are the correct answers. Okay. Question number 4. If we want to separate the blood samples of patients into different blood groups, then the problem is an example of multi-label, multi-class, multi-label binary class, single label binary class, or single label multi-class.
Option D.
It's a single label multi-class. Okay. Can you explain why is that?
Only one label is associated with each data point, but we have multiple class in this blood group like A, B, O. So,
That is true. That is true. So every person, so the possible values of any blood group of any person is, for example, A plus minus, B plus minus, O plus minus, and AB plus minus. So basically there are 8, right? And every person can have only one label. They cannot have O plus and AB negative. That's not possible. So we have multiple options for the class, therefore multi-class, but every person or every blood will be associated, every blood group has only single label, cannot have 2 of them. And that's why option number D. Question number 5, in machine learning, which of the following are model-based approaches?
Generative,
Generative, okay.
discriminative.
Discriminative, okay. What
Is
about
it
instance-based?
instance-based?
So
No, I think
instance-based,
it is.
pardon me?
I think it is.
Instance-based,
Mm-hmm.
okay. I think instance-based should not be the correct answer, but let's go ahead with it and see what portal says. So instance-based is, for example, k-means. Not k-means, sorry, KNN, where what you have, instead of learning the underlying pattern, which is being done in generative, and discriminative is underlying the focusing on the differentiating properties only. That's a discriminative model. And instance-based model is where we want to remember the instances of the data set, and for every prediction we use those instances, right, and not the underlying model learned from it. So I think instance-based should not be the right answer, but let's see. Okay, so the last one, as we talked about, yes, this is not the correct answer. Instance-based, only generative and discriminative models are model-based approaches. So for generative models, for discriminative models, what you want to do is you look at the features. The model tries to differentiate between 2 classes. If you take example of 2 classes, and it focuses on differentiating features only. Generative model is a model in which if we give a new sample to it, it generates. Pardon me? So generative model is it tries to learn the model of the 2 classes, and then whenever a new sample comes in, it compares that new sample with the 2 models, and whichever model it is closer to, that is your prediction. And there's one more mistake we have made. I think it should be here. Semi-supervised learning is also a type of machine learning paradigm. Okay, now all our answers are correct. Any questions so far? Okay, let's go to next set of activity questions. Okay, zooming too much. Okay, so activity question 1.6. Venu wants to estimate the price of a house based on some characteristics, which are number of rooms in the house, area of the house, proximity to railway station, and so on. There could be more features. Which of the following is the output label in the above problem?
House price.
House price, true. So that will be our label. So proximity to railway station, area of the house, number of rooms will become features, and house price will become our label. Question number 2. Validation data is used for tuning the hyperparameters, reducing the weights, increasing the coefficients, all of the above.
Tuning the hyperparameters.
Right, tuning the hyperparameters. So hyperparameters, can anybody tell me what is a hyperparameter?
Some properties of the model which we don't optimize during this optimization procedure, and each epoch or some each iteration, we don't optimize those parameters, but those are properties of the machine learning model itself.
Okay, I'm able to understand what you're saying. Can anybody else wants to also want? Can anybody else also tell me what hyperparameter is? Okay, so can you give me an example of hyperparameter?
Number of batches.
Number of batches. Fantastic example.
I saw it in MLP lecture. That's why I remember it.
Okay. So yes, you will see examples of hyperparameters. So hyperparameters is any parameter of your machine learning optimization process which is not part of your model. Okay, so any parameter which you change and send it out in the output as part of the model is actually a model parameter, and anything else which is not there is hyperparameter. Batch size is definitely an example of hyperparameter. Learning rate is another example of that, and you will see those in week 2. Okay, so if you don't understand what hyperparameters are thoroughly, you will definitely do that in week 2. Okay, question number 3. In k-fold cross validation, how many partitions of the data are used for training a model?
K minus 1.
K minus 1. Great. Yes. So 5-fold cross validation, that means we are dividing the data into 5 subsets. One of them will be used for validation and the remaining 4 will be used for training. Yes. So K minus 1 should be the right answer. Question number 4. Categorical attributes can be converted to numbers by using which of the following?
One-hot encoding.
One-hot encoding. Anything else?
All of the above.
Pardon me?
Fourth option, all of the above.
Hashing.
Yes, like first, second, third, all of them. So fourth option.
Yes, all of them can be used to convert categorical attributes to numbers. So one-hot encoding and one-hot encoding, you will definitely all these 3 things you will see in machine learning practices, but in techniques we will assume that the data set is pretty much pre-processed.
So this is what we meant by having a proper input, like, right?
Yes, true. So as we talked some time back in this session only, that the data set could contain categorical features. I mean features in string formats, city, gender, and there could be something else also. If you want to create features out of them, we will have to use one-hot encoding, hashing, or embedding, or one of these techniques. So in techniques, we assume that we don't have to do this kind of pre-processing. In ML practices, we assume that we should be ready for doing any kind of pre-processing. Okay, does it make sense?
Yes, sir.
Okay, let's go to next question. Class imbalance problem occurs if there are too many examples of one class in the training set, if there are too few examples of one class in the training set, if there are more than 3 classes in training set, if there are more than 4 classes in the training set.
A and B.
A and B, true. So let's take an example of this blue and orange or cat and dog or anything else. The positive class has, let's say, 100 samples, and negative class has 1 million samples. Then it is a case of class imbalance, because both the classes do not have equal or almost equal number of samples. Let's check our answers. Yes, all of them are right. Any questions so far?
Sir,
Yes.
this is Venu here.
Yes, ma'am.
I have a question regarding the process for k-fold validation. Can I ask? Or
Sure. Go ahead.
So in k-fold validation, the number of partitions and number of examples are same, right?
The number of partitions and the number of examples are the same. No, I do not think so.
Okay,
So
k-fold validation is called as leave one out validation, right?
No. K-fold cross validation is okay. Let's say you have 100 samples in your data. Okay. And
okay, sir.
you want to perform a 5-fold cross validation. Okay. So what you do is you divide your entire, first of all, you randomize your data. And then what you do is you create 5 subsets of those samples. And each subset or each group will have 20 samples only. Since there are 5 folds and 100 samples, therefore each fold is going to get 20 samples, 20 examples.
Yes, sir.
Okay. So here the number of examples is 100 and the number of folds is 5.
Okay, sir. Here, so how many total runs would be there?
Right. There would be exactly 5 runs.
Yeah. Okay. So if I divide this 5 partitions as P1, P2, P3, P4, P5, the first run would be, let's say P1 is for validation and P2, P3, P4 is for training.
True. Right.
So second run would be like P2 validation and P1, P3, P4 to be training and so on. So it would be 5 runs, right?
Exactly.
So for each run, the end of the each run, we would get a optimally parameterized model, right?
After each run, we can get a model. Yes.
Then we test that, we check that model on test data and use some evaluation metric and try to determine which is the best. That's right, sir. Right, sir?
That is true.
Okay. So in the lecture, it was mentioned average K values. So I was confused with that. What does average K values mean?
Right. So once you train the model using k-fold cross validation, then how would you report the training error?
What does the training error mean? I mean, there is loss, I know, but what training error is?
Training error is actually loss. So what you will have to do is you have to for this entire process of cross validation, if I ask you what is the loss function, what is the loss value or a training error, you will have to take the average of training errors you received by training your model 5 times using those 5 folds cross validation.
So we would have training error, right?
Pardon me?
So that way we would have 5 training errors, right?
Yes. And you want to report the average of it.
Okay. So for 5-fold validation, there will be one average training error.
Yes. Yes.
Okay,
Sir,
sir. Got it.
Yeah. Okay.
is batch training and k-fold validation one and the same thing?
So can you please repeat your question?
Is batch training and k-fold validation the same thing?
Batch training. So is this batch keyword coming from batch gradient descent?
No, sir. Like batch, like breaking up the data set into small parts and then training it, and k-fold validation. Like, are they the same thing?
No. They are different. So again, batch gradient descent, batch training is like using any training algorithm, but instead of using the entire entire training set, you use uh, small batches of that training set, and you do not evaluate your model right after training on a single batch. You train your model on the all the batches in the training set, okay, and you run number of epochs. You train the model for number of epochs, and once your training is complete, then you do the evaluation on a validation set or some
Okay.
evaluate your model on test set.
Okay.
So batch training is different than cross validation.
Okay. Thanks.
Yeah. Okay. Let's go to next set of activity questions. Okay. Now we are coming to more mathematical parts of machine learning. So, correct expression used in gradient descent algorithm is, which one of them is right?
Option B.
Option B. True. So basically it says in iteration t plus 1, how would I calculate the weight parameter with the help of the weight parameter in iteration t or the just previous iteration. Yes. So the option B is the correct one. You can look into the slides on lectures also. Question number 2, learning rate helps in making loss zero, controlling the step size, testing the model, validating the model.
Step size, controlling the step size.
Right. Question number 3 is stochastic gradient descent is mini batch gradient descent with only one training example in every batch. Is it true or false?
True.
It is true. Question number 4, we prefer batch sizes as powers of 2 to have optimal input output performance, to make algorithm converge faster, reduce training loss.
I think option B, it converges first.
Option B, to make algorithm converge faster.
So I think it's option A.
Option A.
Yes, sir.
Yeah, I also think it should be option A. Okay, let's see. Question number 5. For large learning rate, gradient descent always works better. The chances of reaching the optimal point increases. Optimal point may be overshot. And option D, none of these.
Option B.
C.
Sorry, C. Option C. Yeah,
Option C. Yes. All right, let's check the answers. Okay, all our answers are correct. That means the question number 4 has correct answers as to have optimal input-output performance.
So can you explain the fourth question, like why does it help in optimal input-output performance?
This one?
Yes, sir.
I think it is associated with the sizes of data chunk that you store in your main memory, which is RAM. Because in RAM, the amount of memory which is available is typically power of 2, right? It's, for example, 128 megabytes or 6, no, sorry, 2 gigabytes, 4 gigabytes, 6 gigabytes, 8 gigabytes, and sorry, not 6, but maybe 6 sometimes, but definitely 4, 8, and things like that. So if you, I think it is associated with the fact that the memory addressing happens in binary uh, process, right? So what you do is you read memory locations and write to them with the help of binary addressing, and because of that, to have the batches a size of power of 2, your optimal your input output performance is optimized. Does it make sense?
Yes, sir. So basically, we store the information in RAM, and
Yes. So the data the batch that is being used to train a model, it is always the data set, that batch is stored in main memory.
okay, sir.
Okay.
So just a quick question, if you have
Sure.
not covered it already. I think at some point the professor says that the loss function is most likely to be convex. Of course, there can also be non-convex loss functions, but generally, why is it the case that the loss functions are convex? Just to get an understanding, because I think a lot of it depends on the optimization, depends on the assumption that the loss function is convex, right?
You're absolutely right. So your optimization process is entirely dependent upon the nature of loss function. So for regression, you can easily use sum of squared error, mean squared error as your loss function. It is known to be convex. So if you have a convex function, that means that simplifies a thing for you, a lot of things for you. For example, if it is a convex function, that it is guaranteed to have an optimal minima, or it could have multiple, but it will definitely have one of those. Right. And second is, so if you have a convex loss function, you will not be stuck into local optima. That is one good thing. And second thing is, we have good set of algorithms or optimization procedures to come up to the global minima, and that's a nice thing about convex functions.
Right, and maybe this will be covered later in other weeks. But are there techniques to ensure that the loss functions are convex? I mean, I'm just trying to figure out whether we design models in such a way that the loss function becomes convex, or how do we go about it? Is what I was trying to figure out.
How do we choose the loss function? Is that the question?
Yeah, I mean, do we deliberately choose models for which the loss functions will be convex, or are they two independent things? How is the choice of the loss function based on whether it is convex or not?
Okay, that's a good question, a rather deep one.
Or I mean, if you want me to hold off till a few other weeks, I'm okay with it. Just because the professor made a note there, it was because a lot of the optimization hinges on it. So I just thought, man.
Yes, definitely. So I would request you to wait for week 2 because yeah. So this sum of squared error, which happens to be a convex function, that loss function is going to be covered in great detail in week 2.
Okay, sure. I'll wait till then. Okay,
yeah.
Thank you.
Okay. All right. Let's go to question number 1. Consider the following characteristics: high training loss, high validation loss, low training loss, low validation loss. Which of the above characterizes right fitting? So there are 3 types of fitting, must have been explained in the video: underfitting, overfitting, and right fitting. So which of these belong to right fitting?
3 and 4, I suppose.
Low training loss and low validation loss. That is true. So option number C. Question number 2. Underfitting can be eliminated by increasing the size of training data.
False.
Absolutely right. So if you supply more data to your model, your underfitting model, it is not going to make a difference in its, it is not going to make improvement in its prediction. Question number 3. Overfitting can be, yes.
So could you elaborate on the second question, like why giving it more data?
Okay. Yes, sure. So if your model is underfitting, that means it is ignoring the underlying pattern which is present in the data. You can think it like this. So it is so underfitting model is more biased, you can say, and it doesn't want to learn the data. It doesn't have the complexity or power to learn the underlying pattern. So even if you provide it more data, it will still ignore the pattern, right? So providing it more data is not going to help you in the case of underfitting model. So these things will be very clear after week 2. Okay, it's just a side note. Okay. Question number 3. Overfitting can be eliminated by increasing the size of training data. True or false?
True.
That is true. So a similar explanation goes for this one also. So if a model is overfitting, that means it is too powerful. And instead of learning just the underlying pattern, it is also learning the error which is present in the data set, or the, I should say, noise in the data set. So in order for our overfitting model to focus only on the pattern, what we can do is we can increase the data, and this way it will just focus on the it'll become more it will become better and better at predicting the and focusing on the underlying pattern rather than the noise. Question number 4. Increasing the regularization rate can decrease overfitting, can increase underfitting, can increase overfitting, can decrease underfitting. Which one of these are correct? Anybody wants to take a guess on this?
Can increase underfitting, I think.
Okay. And is that the only correct answer? Do you think any other is also right?
I don't know, sir. I forgot about this.
Could you briefly explain regularization rate? I mean,
yeah.
Right. So regularization rate, just a side note, it will also be covered in great detail in week 2. So regularization rate is the quantity which is used to turn up, or I should say turn down overfitting. So how much do we want to penalize our model if it is overfitting? That's what regularization rate defines. So if I increase regularization rate, it is going to decrease overfitting. But if I increase my regularization rate too much, it is possible that my model can start to underfit. Hence, option 1 and 2 should be the correct ones. Let's go to question number 5. A label which is actually true and is also predicted true by the model in a classification problem is called true positive, false positive, true negative, false negative.
True positive.
True positive, yes. Which metric calculates the ratio of true predicted positive values and which are predicted as positive labels?
Third one.
Which one? Third one. So
Yes.
it is saying that truly predicted positive labels and all the labels which are true, or all the labels which are positive.
It's a third precision.
Yes, it should be precision. Let's check our answers. All of them are correct.
Sir, before going ahead, like I had a few questions on. Could
Yes.
you like explain what does F1 score capture?
What is the
F1 score capture?
Yes, F1 score is another metric which is, sometimes, okay, so let me give an example. Let's say I have a data set which has class imbalance problem. Okay, so I have a data set of, let's say, some disease, let's say cancer. Okay, so in my data set, there are a million rows, a million samples, but only 10 of them, not even 10, I should say, okay, let me change the numbers. In my data set, there are 100 samples and one is positive and the rest of the 99 are negative. Okay.
Yeah.
Okay.
Yeah.
So if I train, if I don't even have to train a model to get a very high accuracy. I will say, okay, all samples are negative. Okay. So my accuracy is 99%. Do you agree?
Yeah.
But my model is very poor predictor of positive class. Right, because it is never going to say positive, and I'm going to miss out some of the patients who actually have cancers, but my model is going to predict it non-cancers. So that's a problem, right? So where there is a class imbalance problem, this accuracy does not give you a very good measure of performance of your model. You also want to look at precision recall and FN score. So FN score, if you calculate the FN score of your model, this model, it is going to give you 0. Because even though your accuracy, your precision will be 0 actually, even though accuracy is 99%.
Okay.
Okay. Yeah. So you can definitely explore on this even more. We'll cover classification problem and these matrix in great detail in week 4.
And one more question regarding this. When we are drawing like precision recall curves, in those, like when the recall is 0, the precision is 1.
When
but
the
if
recall is 0, precision is 1. Yes.
So, but when we see the formula for precision and recall, if one of them is 0, like the other should be 0 too, right?
If one of them is 0, precision recall, the other is not necessarily not necessarily going to be 0.
For precision to be 0, the true positive have to be 0, and for recall to be 0, the true positive have to be 0.
That is true.
So aren't they like true positive same in both the cases?
No. See, even though the numerators are same, the denominators are changing. So recall, precision says all the values that this model is predicting positive, how many of them are actually positive? Okay. And recall says all the values which the model is predicting positive. Okay, that is divided by how many positive values are there in the data set. Okay, so there is a subtle difference between precision and recall.
But if we see the confusion matrix in which if the true positive is 0, won't the precision and recall both come out to be 0 because the numerator would be 0?
That is true. That is true.
So, but when we plot the precision recall curve in those, like when recall is 0, the precision is 1. So,
okay. So you're talking about that. Okay, I see your point. See, recall is 0. No. I think it's slightly more complex than that. So can I request you to initiate a discourse thread on this one?
Sure.
I'll add a detailed answers to this question.
Sure.
Okay. Yeah.
Okay.
Okay. Now we are going to the programming questions part. Week 1 practice programming.
Sir, can you able to
Yes.
sir, how to find out accuracy value from confusion matrix?
Yes. So accuracy, all the samples, they go in denominator, and the number of samples in the data set go into denominator. The number of true positive and the number of true true negatives. If you add both of them and put it in the numerator, that gives you the formula for accuracy. So true positive plus true negatives divided by the number of samples in the data set is the definition of accuracy.
That means sum of diagonal by total.
Sum of diagonals. Yes.
Okay, thanks.
Okay, now we are at a position where we are ready to start our practice programming assignments. Okay, so before we start our practice programming assignments, should we go ahead with practice assignment only, which is just MCQ and multiple correct answers?
Sir, I have one request.
Sure.
Since some student only able to access that portal today only after afternoon, so
okay,
couldn't try that so much practice assignment or that practice problem. So can we do some other day if possible? Then we can come with some try. We not want to miss that.
Okay. That is not going to be a problem because this particular week 1 is very light. We can definitely do that in the next session. But for coming sessions, please make note that we will have to do practice assignments as well as practice programming assignments in the same session.
Actually, what's happened that we was not able to access the portal itself. It was not working.
Okay.
So today only it's worked after the 1 or 2 o'clock. So
okay.
Not to see that even what is question or what's the material is there. So
I see.
Yeah, couldn't. So from next time it will be okay, because why I told that there is 2 only session is there. One is that activity and another is for that solve with instructors.
Yes.
So there was no session between that. That's I thought that's. Can you, if between 1 week, can you arrange something for this week only, so we can have that this discussion about that grade this programming as well as the practice.
Okay. So can I ask everyone that this problem of having access to the portal only today, from afternoon or some time like that, is this problem happen to everyone or just a few number of students?
Maybe a few members, I think.
Pardon me?
Only for few members, I think.
Okay, only for few number of students. Okay. Okay. So,
sir, maybe you can create a discourse post, and if the other members have these queries after going through this material, they can vote for another session, and based on that you can schedule another session.
okay. So yes, actually, if I postpone this part for everyone, those students who had access and are coming prepared will not be treated well. So yeah, may I request you to create discourse course for any kind of questions and doubts, and try to learn whatever you can in this session. And since this session will be recorded, you can come back to it and see the recording. Will that work for you? Hello.
Sir, but just more generally, these sessions are scheduled for a Monday, right? I mean, for this time every week. The content of the portal, content of the for that week is going to be released the previous Friday evening. So is the
True.
expectation that we see all the videos in 2 days, like Saturday, Sunday, and then come prepared for this by Monday evening? Is that the expectation? So that, because otherwise we won't be doing justice to these sessions, right, ourselves. So is the expectation that we watch everything in 2 days, or is it better that we have it like 1 day later in the week? I mean, I don't know if that's possible logistically. Whether it's because usually in the previous term, most of the subjects, at least I took, like MLF and so on, we used to start the sessions from Wednesday onwards. Okay. So by the time we would have all at least viewed most of the videos and then come prepared for the session. But having it on a Monday, maybe just cutting it too short, I think. I mean, at least I think so. I don't know what others think about it.
Okay.
So, I mean, maybe just as a feedback, because if you get at least 3-4 days, because all these videos are, I mean, it'll all add up to about 2.5-3 hours. So we need to just digest all of that and then come to these sessions, right? So I don't know if Monday is probably quite close to, you know, as soon as the content is released. So
I also support Mr. Kaushik. Yes, correct.
Okay. So I understand your concern, and I kind of agree with it also. The issue with us is, I mean, there are so many courses at diploma level that are being conducted, and all of them, for all of them, we have to schedule 2 sessions per week, at least 2 sessions, and possibly on-demand sessions. And we do not want to conduct these sessions, in the working hours, let's say 9 to 5.
True.
Because so many working professionals are also part of this learning community, and if you do that, they will definitely miss out. And that's why we don't have many options for slots. So many subjects and so many sessions, and we have limited slots on which we want to conduct. So I would request you to again start a post. I'll definitely take this up to my team and try to think about a solution for this.
Oh, sure. Thank you.
Okay. Now let's go to practice assignment. Question number 1. Which of the following block diagrams is our correct? Can anybody guess?
First one is true.
First one is true. Input output. Machine learning is the
first one and the first one. Yeah.
Input functions models. Traditional programming gives the output. The second one is there's some machine learning in between inputs and outputs, and it gives the functions or models. That is also true. Third one is input functions, machine learning gives the output. No. Fourth one is inputs and output gives traditional programming giving the functional models. No, they are false. So first and second should be correct. Consider the following characteristics. High training loss, high validation loss, low training loss, low validation loss. Which of the above characterizes overfitting?
2 and 3.
High validation loss, low training loss. Absolutely right.
So can you explain why is it low validation loss?
No, it's high validation, low training.
Yes. Oh, sorry. Like, why is it this way?
Yeah. So overfitting means, by definition, that it is performing really well on your training data, training set, but it is performing poorly on your validation set. Okay. So if it is performing really well on your training set, that means it is going to give you low training error. And if it is performing poor on your unseen data or validation set, then it is going to give you high validation error. And that's why high validation loss and low training loss are characteristics of overfitting.
But why is this high? Okay, so it's not able to work on validation.
So your question is, why is it giving high loss on validation set, right?
Yes, sir. Now
Okay.
because it's overfitting.
Okay. Okay. So let me give you an example. Let's say on a let's say a student prepares for a mathematics exam, any standard, 10th standard, 12th standard. He prepares for a mathematics exam, and instead of learning how to solve the problems, he actually memorizes everything. Okay. So all the practice questions, or in the machine learning parlance, training set, he remembers everything. Okay, but he doesn't understand the underlying pattern. So when he goes into the exam and takes the exam, he's not expected to perform really well, is he?
No.
No, right? So same is the situation with overfitting. So overfitting, instead of learning the underlying pattern of the data, it remembers the data. Okay, that's the idea behind overfitting. And when it sees the new data, it is not able to perform really well, and that's why we see high validation loss, but low validation. Low training loss. Does it make sense?
Yes, sir.
Okay.
Sir, is test loss equivalent to this validation loss, or these two are different things?
Test loss and validation loss, they are different.
Okay.
Because the test data, test set, and validation set, both are different. Validation, yeah.
And like validation is used for optimization, right?
So see, there is a possibility of leaking information when you do them. For example, you divide the data into only two sets: training set and test set. Or instead of calling test set, let's call it validation set. Or okay, let's just call test set. Training set and test set. You train your model on test set. Training set, and get the accuracy on test set. You see it is still low. Okay, the accuracy is not good enough. So you go back, you train your model once again, and you test your accuracy on test set, and this time your accuracy is better, or the error is low. So what is happening is your test data is actually, you're using your test data to improve your model, right? So some information is actually leaking back in your training process, and that's why your test accuracy may not be a very good representative of the performance of your model on unseen data, right? So what we do is we divide the data into three parts: training set, validation set, and test set. On training set, we train the model, we get the accuracy and validation model, and if it is not satisfactory, you go back to your training set and train the model once again, and you repeat this loop between training and validating, until you are happy with your model. Once your model is, you're happy with your model, okay, this is your finalized model. You use that model and evaluate the test set, evaluate on test set, and whatever accuracy you get, that is the testing accuracy or testing error, and that's the one you report. You do not repeat this process, or you do not take any information from testing test set and use it to train your model. That's why we have three division of data set: training set, validation set, and testing set.
Can we say the validation data comes from the same distribution as the other test and training data?
Yes. All the data sets, all the data, validation, training, and test sets, they are coming from the same distribution.
Okay.
Okay. Question number 3: which of the following is not a supervised learning algorithm?
With K means clustering?
That is true. Yes. Because clustering itself is an unsupervised learning problem. So any algorithm that solves that problem still has to be unsupervised or not supervised. Question number 4: which of the following label can be considered continuous? Whether it can rain today or not, wind velocity in a cyclone, pitch of a sound wave, intensity of light.
the last three, isn't it? Wind velocity in a cyclone, pitch of a sound wave, intensity of light.
Right. I also agree with you. First option, whether it is going to rain or rain today or not, it's a binary value, true or false, 0 or 1, and hence it cannot be continuous. Rest of the three are continuous properties. Velocity can be 0 to any positive number, and you can also have this value in decimals. Same is the case with option C and D. Question number 5. Which of the following are examples of discriminative models? Logistic regression, SVM decision trees, dual values. Okay, this is little early to answer this question with proper information. So I'm going to help you. Logistic regression, SVM decision trees, and all of them are actually discriminative models. Neural networks can be used for generative models also, but it can be discriminative also. The area under the curve of a precision recall curve for an ideal classifier is
1.
true. Question number 7. A label which is actually false and is predicted true by the model in a classification problem is called
False positive. Actually, false is predicted to have false
it's
positive.
false. It's false positive. Question number 8. During training of a machine learning model, training loss should decrease and test loss should increase. Okay. Option number 2. Training loss should increase and test loss should decrease. Both of them should decrease or both of them should increase.
Both of them should decrease.
Third.
Absolutely right. Yes. Okay. Question number 9. Precision of the classification model represented by the above confusion matrix is okay. For this, can somebody do the calculation and tell me what should be the answer? By the way, how should we go about it? What should be the numerator and what should be the denominator?
62 meters.
What should be the answer?
0.68.
0.60. Okay. So how did you calculate this?
No, 0.68. 8, like 68. 0.68.
Okay, 0.60. Okay. So how did you calculate this?
So I did 62 divided
Okay.
by 62 plus 28.
62 divided by
62 plus 28.
that is right. Yes. Out of the positively predicted values, how many of them are actually positive? That's the definition of precision. Right. Let's go for recall. The value of classification model represented by the above confusion matrix is
0.62.
0.62. Okay. How did you calculate this? Hello. Hello.
62 by 62 plus 38.
62 divided by
62 plus 38.
62 plus 13. I think it should not be 62 then. It should be lesser than that. And this one should be 62 because 62 divided by 62 plus 28 is 62 by 100. So this should become 62.
No, sir, 90.
Oh, you're right.
62 plus 28, 90.
Right. Okay. Okay. Right. And this becomes 62. Okay. Right. Let's check our answers. Okay. Okay. We got one of them wrong. Which one is it? Accepted answers are machine learning auto results. Okay. What did I? Machine learning gives functions and models, inputs and outputs. Traditional
The
programming
question
gives.
about the
Are
incorrect.
incorrect. Are incorrect.
Incorrect they are asking.
No answer is incorrect, is it?
No. I think the question is the incorrect pictures. They wanted the incorrect ones. We have marked the correct ones.
Okay. Okay. You're right. These should be the correct answers. All of them are right now. Okay. Okay. So now we come to the point where we can start with our programming assignments. Okay, so what about this? Since we are already close to our 8 p.m. mark, why don't I start with the practice assignments of week 0, which are going to help us a lot in the practice assignments of week 1. And I'll finish the practice assignments of week 0 today and practice assignments of week 1 in the coming session. Does that work for everyone?
Okay. Okay.
Okay. Yeah. All right. So I hope that you have gone through the materials provided for Numpy, which is on vectors, matrices, and some additional functions of Numpy arrays. So let me go to the first practice assignment. Okay. What is the shape of the following Numpy array?
+3.
Oh, sorry. So the answer is already filled in.
Yeah.
So the correct answer is 2 by 3. The reason for that is there are exactly 2 rows. One row is this one, and the second row is this one. And first row has 3 elements, and the second row also has 3 elements. So the size of the array has to be 2 by 3. Question number 2. What is the output of the following code snippet? Array A is equal to 1, 2, 3, and array B is 4, 5, 6.
5, 7, and 9.
5, 7, and 9. How did you compute that?
It is just adding these two arrays. These are 1 + 3 matrix, so they are just adding this.
That is true. So in order to add those two arrays, all we have to do is do the element-wise addition, right? 1 + 4, 2 + 5, 3 + 6. And that gives us 5, 7, 8, 9. Okay. Okay.
They are like 2 square brackets in B.
Okay. See this one. Why don't you execute this code and see? Yeah, let me open up. So I hope that you know we are going to use. Okay, I'm going to create a new Google Colab. We are going to be using Google Colab quite frequently in machine learning practicing techniques also for demonstration and solve with instructor live sessions. So let me just copy paste the code and execute it.
Then you have to import the library Numpy.
True. Yes, I forgot that. Oh. 5, 7, and 9. And if I want to see its shape then also I can see it should be 1 by 3. Yes. So your question was, in one of the places we are seeing square brackets, in the first one A we are seeing normal parenthesis, right?
Yes, sir.
Yes. So if you use square brackets or normal parenthesis, it adds another dimension to your layer. Sorry, not your array, and that's why this kind of output is being seen.
So this round bracket as time mentioned.
Yeah, this round bracket and this round bracket, it says that it is part of another array. This thing is inside another array.
And what about the double square bracket?
Right. So this is list inside a list, and this is list inside a tuple.
So how do they add? I don't understand.
How do we?
How do a tuple and list add together?
How is a tuple added into a Numpy array?
No, how a tuple is added to a list?
Yeah, right. They are not added. So this list is inside a tuple, and this tuple is actually from this tuple we are creating a Numpy array. Okay, and when we are creating array B, we are doing a similar thing. This is a list inside a list, and from that we are creating an Numpy array called B. So if I want to see the type of both of these, I can type this. Type of A is okay. I exclude both these two statements. I can see the type of both A and B is ND array, which is a class of Numpy library. Okay, so it doesn't matter if we are creating this array from a tuple or a list. The final type of the array which is being created is going to be Numpy array. Okay.
Yes, sir.
All right. Let's go back to our questions. Question number 3. Consider the vectors x and y. Which of the following commands? Which of the following commands prints the dot product of the two vectors?
So we can add
X
add
ampersand
product
y.
by the, yeah, x dot xy.
Okay, so there are basically 4 options. One option is just use the normal asterisk multiplication sign. The other one is use the numpy dot function.
Mm-hmm.
The third option is use numpy dot sum after you multiply the two numpy arrays using asterisk or normal multiplication, and the first one is you use the @ sign. Which one of these is going to give you the dot product or the vector
C and
product?
D. And the last
C and
1, 3.
What about A?
So A should be x dot t and then @ y, right? So because x is a 3x1 matrix and y is also a 3x1 matrix, so I first have to transpose the x and then only I can do the dot product, right?
Okay, that's a very good explanation. I want to add to just one thing to that understanding. Okay, so here you can see that let me create another array. I'm going to call it T numpy dot array, and I'm going to create an array out of just a list, and I'm going to call it 1, 0, 1. Okay, no mistake. Okay, what should be the shape of this?
1 plus 3.
Are you sure?
3, 1.
3, comma 1. Okay, let me see.
Just 3.
Just 3.
Oh, okay, I understand.
Okay.
By
So,
default, it is 1.
yeah. So there is a subtle difference between Numpy arrays and the vectors and matrices that we use in mathematical notations. Okay. So please keep that point in mind. Sometimes, so the vectors which we have, like say 5 cross 1 or 1 cross 3, as dimensions in mathematical notations, when we come to implement that into our Numpy with the help of Numpy arrays, the shapes are not exactly same. So we have to be a bit aware of that and be cautious also. Now, what happens if I print the t, just the array? Okay, I am going to see 1, 0, 1. That works perfectly fine. What if I want to see its transpose? What do you think I'm going to see? If I execute this, I'm still going to see the same thing. Okay, so transpose happens in Numpy library if the array has 2 or more dimensions. If it has only 1 dimension, transpose is going to give you the same array itself. Okay, maybe I can try with some other number, 1, 0, 5.
So, sir, if I add one more third bracket before that, then it will add one more dimension, and then I will have 1 plus 3, right?
Something like this?
Yeah, then it should be 1 plus 3.
Yes, now it is going to give you, now it is a 1 cross 3 matrix. And if I transpose it, I'm going to get a 3 cross 1 matrix.
Okay, I understand. Thank you, sir.
So the correct options for this question should be 1, definitely C, and definitely D also. So normal multiplication or status operator is going to multiply the two vectors element wise, and if you do the numpy dot sum, it is going to give you the right answer. And at the rate is another way of doing the dot product or vector product.
Sir?
Yes.
Fourth one is correct, sir. There is some actually, no?
Yes, numpy dot sum.
There is some in bracket x and dot y. This will be incorrect, sir, I think.
Okay, let's see.
I think, sir, first and second and third will be correct. Second will also be correct, sir.
Okay, let's try that. Okay, we have two vectors right over here. I'm going to remove the something like this. Okay, I'm just going to create one dimensional vectors, and let's print A star B. Okay, you're saying that this should give us the dot product. See, instead of giving us a dot product, it is multiplying the vectors element wise. Right.
So this is also dot product, no, sir? If you find a dot, this is all, since this is a vector. So element wise multiplication will be equal to dot product here.
See, dot product. Okay. Which are the following commands which is the dot product of the two vectors? I think this in this question, dot product is not element wise product.
Sir, actually this is a vector, sir, not a matrix. If x and y are matrix, then that will be different. We are taking here, so B will also be correct.
See, B can I don't think it is going to be correct because it is just going to it is going to give you a matrix and possibly a matrix given that and it will always multiply elements the vectors element wise, but not it is not going to give you the dot product.
So it's asking for the dot product, right? Not for matrix multiplication.
See, dot
product is basically individual multiplication and the sum of the individual element multiplication. It's the typical vector dot product only, right? So that's what it is.
Yes. True. So the second one is not going to give you the summation, right? It is just going to multiply the vectors element wise. But in the dot product, you want to also get the sum of those, right?
Yes.
right? So the second one, second option, that's why it's going to be incorrect. First, see, okay, I get your point. So this @ sign can be used for, in this particular case, since we have two vectors, it is going to give us the dot product. Otherwise, it can give us the vector product also. If we had matrices of of different shapes, for example, 3x2 and 2x3. Okay, moving on to question number 4. What is the output of the following code snippet? W is equal to numpy dot 0 is 5. W is equal to W plus 2. What should be the output? What should be the answer?
5 2 should be printed. Maybe.
Option number 1.
No, 5 2. So last one. Numpy dot 0 initiates 0 matrix and then 0 vector, and then I'm adding 2.
Can you tell me how did you come to this answer?
So numpy dot 0 5 is creating all 0 matrix, all 0 vectors. So after that, I am adding 2 to all these entries.
Right. So what is the concept, underlying concept in action here? You are adding a number to a vector.
Yeah.
So how are you adding just one number to a vector of 5 elements? Okay, so this question is just to, your answer is absolutely right. This question is just to focus on the underlying idea of broadcasting. So when you are adding a number to a vector, it is broadcasted as the same size of the vector in which it is added. Okay, so this will also become an array of 5 elements. Each element will become 2, and then 0 plus 2, 0 plus 2 will happen 5 times, and then you get this answer. Okay. Just a side note, let's go to question number 5. Numpy dot linspace a, b, comma, n is a method that returns an array of evenly spaced points between a and b. Both a and b are inclusive. Okay. For example, numpy dot linspace 0, 1, 5. So I want 5 points between 0 and 1.
Sir?
Yes.
Can I ask one question,
Sure.
sir? Can we add vector plus scalar, sir?
Yes, we can add a vector plus a scalar. This is how it's done. W plus 2.
Yeah, that's all. Oh, thank you.
Yeah. So how it will happen is W is a array of zeros. All 5 elements of W are 0, and you are adding a scalar 2. So what will happen is it will be, this scalars will be added to every element in the vector W. Okay, let's go to next question. Numpy dot linspace a, b, n is a method that returns an array. Okay, we were there. Now, if we call numpy dot linspace 0, 1, 5, it is going to give me 5 points starting from 0, and the last value will be 1, and there will be evenly spaced 3 more points between 0 and 1. So 0, 0.25, 0.5, 0.75, and 1.0. Now, once you know that numpy dot linspace gives you this kind of output, what should be the output of following code? Numpy dot linspace -1, 1. There is 5. So we want 5 equally spaced points between -1 and 1, and then we do this operation and print y. What should be the output?
3, 4, 5, 6.
2, 3, 4, 5, 6.
Option C.
Absolutely right. So if I want to decompose the answer into, let's say, so let me comment for a minute this particular line and this line also. Just print x. So what's going to happen is I'm going to get 5 equally distributed points between -1 and 1. So -1, -0.5, 0.0, 0.5, and 1. Now in the while I'm calculating y, I'm multiplying this by 2. Okay, so if I multiply this by 2, I'm going to get -2, -1, 0, 1 and 2, and then after that I'm adding 4. Okay, so if I add 4 to all these values, this will become 2, this will become 3, this will become 4, 5 and 6, and this should be the correct answer. Yes, option C.
So
Question
the
number
general
6.
approach, just the general approach for line space would be that we calculate the interval between the start and end point and divide it by the number of points we need. Is it? I'm just trying to figure out how we get that -1 point, -0.50. If we were to
Right,
just
right.
work it out on paper.
Okay, okay. So
yeah.
In order to do that, I would say see for this one 0 and 1. So the difference between every two consecutive pair of points is 0.25, right? So what you do is 1 minus 0 divided by 4, which is 5 minus 1. That will be the interval.
Okay, there are 4 intervals, and therefore I just add
Exactly,
divided by
exactly.
4, I guess.
Yes, yes.
Okay.
Same issue, same thing you can apply over here. -1 minus -1 is 2, divided by 4 is 0.5, and that's why the difference, if you remember this one, I just remove everything, it turned out to be -1 minus 0.5, 0, 0.5 and 1.
Right, right.
Okay,
okay, thanks.
Yeah. Let's go to next question. Find the product of these two matrices using Numpy. So for this particular question, you can do this in two ways. One is either you can write these two matrices in Numpy and execute the code, or you can just quickly multiply first row and see what is the output. So 1, 2, 3, 7 plus 18 plus 33. It turns out to be 58. Okay, so this is the same in both of them. Let's get the second element of the first row. 8 plus 20 plus 36. It turns out to be 64. So I think, yeah, first should be right answer. Consider the following matrices and vectors. We wish to compute the following expression, ax minus b. Which of the following, how does this work in Numpy? Okay, this is an interesting one. So the first three lines of both the options are actually just initializing a, x, and b. The difference comes in the last line. How do you multiply these two matrices, a and x? Whether it should be star or it should be at the rate.
At the rate. That's what does matter.
Yes, that's vector multiplication. That should be the correct answer there. You can also check it by looking at the dimensions of the matrices. For example, a at the rate b. So a has the dimensions 3 by 2, x has a dimension 2 by 1. So the product of a and x should be 3 by 1, and which is same as the size of b, 3 by 1. So yes, b should be the correct answer.
So just a quick question there.
Yes.
So the a dot x, I mean a multiplied by x is 3.1. Sorry, 3 cross 1 matrix.
I don't think it is going to give you.
This is 3 cross. Sorry, this is 3 cross 2, and that is 2 cross 1. So ax is going to be 3 cross 1, isn't it?
Okay. Let's see this. Let's try to find it out.
I'm just wondering why expandims is not required for B for the broadcasting. So that is my question really.
Oh, so why do we? The reason for that is after you multiply matrices A and B, A and X, you get a matrix of size 3 by 1.
1, correct.
Right, and the size of B is also 3 by 1.
It's
right?
only
So
3 by 1. Okay.
yes, and that's why you don't need any broadcasting. So broadcasting comes in when one of the dimensions is same and the to be more specific, first dimension is same and the other dimensions are not.
Okay. Okay.
Yeah.
Okay. Fine. Thanks.
Okay, we wish to, question number 8, we wish to add the vector b to every row of the matrix M. Okay, so what should be the correct answer? So basically it is asking you, so first first 4 lines of both the options are actually just initializing the matrices B. The next line, how the last line is also same, M plus D. The only difference comes in whether we want to increase or sorry, increase the increase the dimension of B or not. Okay, can anyone tell me? Okay, so whenever you have doubt in such kind of questions, the best answer is just open your Google Colab, copy paste the code, and execute it. See, it is working. Now, can anyone tell me the reasoning behind it?
So B is a 3 cross 1 vector and M is also 3 cross 4. So it's just adding B to all these columns of.
Okay. To say the same thing in a different manner, this one row will be broadcasted into a matrix of 3 by 4, and every row of that new matrix will have exactly these elements 1, 2, 3, 4, and that's why we are seeing this answer M plus B. Yeah. Okay, question number 9. Now this one is a bit interesting because instead of adding the elements row wise, it is asking that you want to add the elements column wise. Now what's going to happen?
To increase the dimension.
Yes, this time we will have to increase the dimension because see, if we add this, if we take just the first element of this matrix or the first row, the number of elements in this second vector, which is B, are not same. Okay, so what we want to do is we definitely want to increase the dimension so that broadcasting could happen. Okay, that's why we do this. Can anyone tell me x is equal to 1 and x is equal to 0? What is the meaning of this parameter in expand underscore DIMS function?
Sir, x is 1. X is equal to 1 represent column wise. X is equal to 0 means row wise.
Oh, okay. Can you repeat that?
Sir, x is 1 represent like column.
True.
And x is 0 means row.
Okay. So please keep that in mind. For single dimensional arrays and two dimensional arrays, the axes have different meanings. For two dimensional arrays, x is 0 is the I agree with you, rows, and x is 1 is equal to column. So what I'm saying by this statement, what I'm saying is there are already rows in my B is actually a single dimensional vector, and I want to add another dimension to it, which is a column. Okay, so let's see how it looks like. Okay, just let me add something like this. If I try to add, of course, it is going to give me an error that operands could not be broadcasted together. Okay, 3, 4 and 3. So if I is equal to numpy dot b comma x is equal to 1, and then if I print just b, this is how it looks like. Okay, now it is a 3 by 1 matrix or vector, you may call, since it has only one in the second dimension it has only one value. You can see its shape also, 3 by 1. And now if I add m and b, okay, now it is going to add one this column or 1, 2, 4 column wise to every column in M. Okay. Okay, subit has a dimensions in numpy axis, numpy array, sorry, numpy library differently. So if I do this and b is equal to b dot transpose, this is still going to show me error, because if I transpose a one-dimensional array, I am still going to get one-dimensional array in numpy. Okay, there's one more thing you can do is, which is reshaping. You can do it something like this, -1, 1, and then it works. Because what I'm saying is, I want to add one column, and the number of rows you can reduce. Since there are 3 elements, there will be 3 rows and 1 column, and this is how you can also reshape your array or change the dimensions. Okay, let's go back to our assignment. What is the output of the following code snippet? Okay, this is an interesting one. Can you tell me what should be the answer?
It will be the second row, which is A1, right? Second row and second, and if you use 0 index, it will be second, 0, 1, third and fourth elements, 8 and 9.
8 and 9. Fantastic. Yes, absolutely right. Question number 11. Consider the following code snippet. What does B correspond to? Okay, so there is a matrix we have, numpy array. In all the options, we use normal indexing and non-zero indexing to refer to the rows and columns. Okay, it is the third row of the matrix A. It is the third column of the matrix A. It is the second row of the matrix A. It is the second column of the matrix A.
The third column.
Third column.
Okay, what does B correspond to? It represents the third column. Yes.
So what does colon mean?
Colon means, see, so whenever you want to access any element of an array, especially 2D array, you give indices. For example, 0, 0 will give you the first element. 0, 1 gives you the second element in the first row, and so on, right?
Yes, sir.
What if you want all the elements in a row belonging, yes. So instead of, sometimes you want to choose an entire column or entire row. So if you want to, so 2, 2 represents the index of the third column. And in that third column, you do not want just one value, you want all the values. Okay, so you write column. So what it means is, in third column, give me first value as well as second value, third value, all the values of that in that column. Okay.
What about all values of a row?
We can do that also. Let me copy this and show you. So code. I should B. see 3, 7, 11, 15. So 3, 7, 11, and 15. If you want to see all the values in a particular row, let's say if I want all the elements in second row, and I want to select all the values from all the columns. So if I'm going to write colon after the comma, and here you can see 5, 6, 7, 8, which is 5, 6, 7, 8. Okay. Let's go to next question. Question number 12. What is the output of the following code snippet? Print a dot sum x is equal to 0. This is an interesting one. So by the way, it is going to add one. So question is basically this: is it going to add 1, 4, 1, then 1, 5, 9, or is it going to add one row at a time?
Using some axis equal to 0 will add the columns, right? So I mean, we say 1, 4, 1, 1, 5, 9, 2, 1, 10, 3, 4, 11.
Absolutely right. Absolutely right. Yes. So this should be the right answer. Okay. So here at the end.
But I think in the portal the answer is wrong though. Or has it been corrected?
It is correct. 6, 15, 13,
okay,
18.
okay.
Okay. So we got all. Okay, one answer we got wrong. Which one is that? We talked about it correctly, but by mistake we chose the incorrect answer. Okay. So all our answers are correct now. Okay, so there are 3 more programming assignments, actually 4 more programming assignments, and some programming assignments from week 1 as well. So look at the clock. We are already half an hour past our scheduled deadline. Is it okay if we cover this in the next Solve with Instructor session?
Yes, sir.
Okay, does that work with everyone?
Sure, sir. That's fine.
Okay, great. So thank you for allowing me to take additional half an hour for this session. Thank you for being patient. And for anything that you wanted to be covered in great detail, please start a discourse forum theorem. Discourse forum thread, and I'll take a look into it.
Thank you, sir.
And yes. And the programming assignments from week 0 and week 1, as well as Solve with Instructor, we'll cover in next session. Okay, thank you everyone.
Thank you so much.
Yeah.
Thank you, sir.
Have a good night. Yeah. Bye bye.